Welcome to the Explainer. Today, we're diving straight into the absolute chaos of recent AI releases. We're going to bridge the massive industry-wide panic we've all been seeing with the actual underlying science of how these brand new models think. And most importantly, we're going to show you exactly what this means for your daily workflow. It's a wild ride, so let's just jump right in. Let's start with a number that tells you literally everything you need to know about the incredible pressure OpenAI is under right now. 48 hours. That's it. That is the incredibly brief, almost unbelievable gap between the release of their model GPT-5.3 and its immediate replacement GPT-5.4. To really put that into perspective, remember the agonizing wait from GPT-4 to GPT-5? That took over 2 years of careful development. But then, on March 3rd, 2026, OpenAI dropped GPT-5.3, a model that actually had great real-world utility, by the way, only to make it completely obsolete just 2 days later on March 5th when they pushed GPT-5.4 live. This wasn't some planned product roadmap. No, this was a total fire drill. Which brings us to Section 1, the benchmark battle. So why the sudden fire drill? Well, it was essentially a forced merge of their general and coding branches, and it was driven entirely by the data. Anthropic's Claude 4.6 completely crushed GPT 5.2 by 144 ELO points on real-world professional tasks. And when you look at pure coding on the SWE Pro benchmark, both Claude and Google's Gemini 3.1 Pro were hovering around an 80% success rate, while OpenAI was totally stuck down at 49.1%. People weren't just saying the competitors were good, they were saying they literally felt smarter. OpenAI simply had to ship a response. That leads right into Section 2, how AI actually thinks now, using the Mars framework. To understand exactly how OpenAI bounced back so incredibly fast with GPT 5.4, we really have to zoom in on the underlying science of how these new large reasoning models actually think. Think of this architecture exactly like your own brain's dual-process cognition. You've got System 2, which handles the slow, deliberate planning, the complex reasoning, and deciding which tools to call. And working right alongside it, you have System 1. System 1 operates fast, it's intuitive, and its entire job is summarizing massive amounts of external information so that the deliberate System 2 doesn't get totally overwhelmed by the sheer volume of data. But how do they actually get these two systems to talk to each other seamlessly? It's all thanks to a fascinating algorithmic technique called bin packing. When the AI pulls in pages and pages of noisy data from the web, bin packing mathematically chunks up all that variable length content into perfectly sized packages that System 1 can process in parallel. Let's look at the Mars framework in action. If System 2 decides it needs to solve a super complex problem, it might ask for computations from a Python interpreter and pull deep academic research from Google Scholar. System 1 immediately steps in, uses that bin packing technique to perfectly organize these massive tool outputs and filters them into distilled, concise insights. It basically hands only the essential need-to-know info back to the reasoning engine. It's an absolutely perfect division of cognitive labor. Moving right along to Section 3, your computer's new co-pilot. Now you might be wondering, how does this massive architectural upgrade actually translate into your day-to-day work? Well, it arrived in GPT 5.4, introducing true computer use. We are talking about the ability for the AI to navigate your actual desktop, click and type across your applications. On the OS World benchmark, which tests exactly this kind of simulated mouse and keyboard control, GPT 5.4 scored an incredible 75%. To put that in perspective, the human baseline is 72.4%, and the previous model was stuck at just 47%. You don't just type a question anymore, you give it a goal, like, hey, review this spreadsheet and email a summary, and it executes the steps entirely on its own. But hey, an autonomous agent is really only useful if it's accurate, right? Because GPT 5.4 is leaning so heavily into that deliberate System 2 thinking, they've introduced what they call an extreme reasoning mode. By throwing significantly more compute at verifying answers before speaking, factual claims are 33% less likely to be false compared to previous models. This means you can actually start trusting this AI to act as a reliable junior analyst, rather than just treating it as a brainstorming buddy. Now for Section 4, the Pentagon Guardrail Divide. This massive leap in autonomous capability has triggered a stark, highly consequential philosophical split in the AI industry regarding who actually gets to use this powerful technology. In late February 2026, the U.S. Department of War terminated its relationship with Anthropic because Anthropic flat out refused to remove safety guardrails that blocked their AI from being used for autonomous weapons and domestic surveillance. In response, the government literally labeled them a supply chain risk. OpenAI, however, chose a totally different path, stepping right into that vacuum to sign a classified deployment deal for the Pentagon's networks. We are neutrally observing two completely different corporate philosophies here. OpenAI's CEO, Sam Altman, argued that it was better to actually have a seat at the table, establishing contractual red lines like prohibiting social credit scoring and requiring human control for weapons, rather than walking away and having zero influence over how the government deploys the tech. It is a profound divergence in how these two leading companies view their ethical responsibilities as their systems become incredibly powerful. Which brings us to Section 5, the massive cost of compute. So why take the PR hit of a military contract at all? Because the geopolitical reality is deeply intertwined with the technical one. OpenAI needs a massive government and enterprise funding to build out the physical infrastructure required to train the next generation of reasoning models. Intelligence doesn't scale linearly anymore, it requires exponentially more power. Enter Project Stargate. This is a jaw-dropping $500 billion computing infrastructure build-out. Jointly funded by SoftBank, OpenAI, Oracle, and Microsoft, it represents the largest computing infrastructure project in human history. To truly dramatize the sheer physical scale of what we are talking about here, just one of these Stargate sites, the 250-acre facility in Saline, Michigan, draws 1.4 gigawatts of power. That is literally 25% of that entire region's power generation capacity, dedicated to a single AI data center. And this creates an incredible real-world tension. On one hand, it's the largest economic development project in Michigan's history, generating thousands of union construction jobs and permanent high-skill roles. But simultaneously, it is putting such massive pressure on the energy grid that analysts predict half of the planned global data centers for 2026 are facing severe delays, simply due to power shortages. Finally, Section 6, GPT-6, and the persistent agent. All of this, the 48-hour panic to reclaim the technical lead, the dual-system Mars reasoning architecture, the controversial military deals, and the billions of dollars and gigawatts of power, is feeding into one singular, highly anticipated goal: GPT-6. And the biggest change here isn't just raw IQ, it's memory. We are moving from stateless chatbots that forget who you are the moment you close the tab to a persistent autonomous agent. This system is fundamentally designed to remember your preferences across months, learn overnight via reinforcement learning without needing a full system update, and utilize its computer use skills to continuously act on your behalf. As these advanced reasoning models rapidly evolve from simple text generators into the literal autonomous operating systems of our digital lives, I want to leave you with this final thought from our source material. Looking at the massive multi-billion-dollar infrastructure, the frantic corporate panic to stay on top, and the undeniable scientific leaps in dual-system reasoning, are you more impressed by the capabilities you now have at your fingertips, or are you concerned about where this is all heading? Thanks for joining me on this explainer, and we'll see you next time.